Newton, physics superstar. Isaac Newton was a brilliant scientist. He lived a long time ago. Newton made amazing discoveries about the universe. We still use his laws of motion today. Newton's laws explain how objects move. They tell us about force, mass, and acceleration. These laws are fundamental to physics. Physics is the study of how the universe works. Newton's first law is the law of inertia. This fundamental principle of physics was first formulated by Sir Isaac Newton in the 17th century. It describes the behavior of objects in motion and at rest, and it is a cornerstone of classical mechanics. Inertia is the tendency of an object to resist changes in motion. This means that an object will not change its state of motion unless a force is applied to it. The greater the mass of the object, the greater its inertia, and the more force it will take to change its motion. A resting object will stay at rest unless acted upon by a force. For example, a book lying on a table will remain there indefinitely unless someone moves it or another force, like a gust of wind, acts upon it. This is because the book has inertia, which resists changes to its state of rest. A moving object will continue moving at the same speed and direction unless a force acts on it. Imagine a car driving on a straight, flat road. If no other forces, like friction or air resistance, act on it, the car would keep moving in the same direction and at the same speed forever. This is also due to inertia. Imagine a soccer ball at rest on a field. It will stay there, unmoving because of its inertia. The ball's mass gives it a certain amount of inertia, which keeps it stationary until an external force is applied. It will stay there until someone kicks it. This is inertia. When a player kicks the ball, they apply a force that overcomes the ball's inertia, causing it to move. The ball will then continue to roll in the direction it was kicked until other forces, like friction from the grass or another player's kick, act upon it. The ball wants to stay still. This is a simple yet powerful illustration of Newton's first law. Understanding inertia helps us comprehend why objects behave the way they do, whether they are at rest or in motion. It is a fundamental concept that applies to everything from everyday objects to celestial bodies in space. Newton's second law tells us how force, mass, and acceleration are related. Force is a push or pull. Mass is the amount of matter in an object. Acceleration is the rate of change in an object's velocity. The formula for Newton's second law is F equals ma. This means force equals mass times acceleration. A heavier object needs more force to accelerate at the same rate as a lighter object. Newton's third law states that for every action there is an equal and opposite reaction. When you push on an object, it pushes back on you with the same force. Think about jumping on a trampoline. You push down on the trampoline and it pushes back up on you. This is why you bounce. Section 5. Newton's laws in space, from rockets to satellites. In this section, we will explore how the fundamental principles discovered by Sir Isaac Newton centuries ago are still the backbone of modern space exploration. From the powerful rockets that launch spacecraft into orbit to the satellites that circle our planet, Newton's laws of motion are at work. Newton's laws are essential for space exploration. They help us understand how objects move and interact in the vacuum of space. Without these laws, we wouldn't be able to predict the behavior of spacecraft or plan missions with the precision required for success. Rockets work because of the third law of motion, which states that for every action there is an equal and opposite reaction. When a rocket launches, it expels gas out of its engines at high speed. This action creates a force in the opposite direction, propelling the rocket upward. The rocket expels hot gas out of its engines. This expulsion of gas generates a powerful thrust that pushes the rocket off the ground and into the sky. The engines are designed to maximize this thrust, allowing the rocket to overcome Earth's gravity and reach space. This creates an equal and opposite force that propels the rocket upward. The force of the expelled gas pushes against the rocket, lifting it higher and higher until it escapes the pull of Earth's gravity. This principle is what makes space travel possible. Satellites stay in orbit because of gravity and Newton's first law. Newton's first law, also known as the law of inertia, states that an object in motion will stay in motion unless acted upon by an external force. In the case of satellites, gravity acts as the external force that keeps them in orbit around Earth. Gravity pulls the satellite towards Earth. This gravitational pull is balanced by the satellite's inertia, which keeps it moving forward in a straight line. The result is a stable orbit where the satellite continuously falls towards Earth but never actually reaches it. The satellite's inertia keeps it moving in a straight line. This forward motion, combined with the pull of gravity, creates a circular or elliptical orbit around the planet. The balance of these forces ensures that the satellite remains in a consistent path, allowing it to perform its functions such as communication, weather monitoring, or scientific observation. These two forces balance out, keeping the satellite in orbit. The delicate equilibrium between gravity and inertia is what allows satellites to stay in space for extended periods, providing valuable data and services that are crucial for modern life. Understanding Newton's laws helps us design better spacecraft and plan more efficient missions, ensuring the continued exploration and utilization of space. Section 6, Safety First, How Newton's Laws Keep Us Safe. Newton's laws of motion, formulated by Sir Isaac Newton in the 17th century, are fundamental principles that govern the behavior of objects in motion. These laws are not just theoretical concepts. They have practical applications that are crucial for our everyday safety. Newton's laws are crucial for designing safe vehicles. Engineers and designers rely on these principles to create systems that protect passengers during accidents. For instance, crash tests are conducted to understand how vehicles behave under extreme conditions, and this data is used to improve safety features. Seatbelts protect us because of inertia. According to Newton's first law, an object in motion will stay in motion unless acted upon by an external force. In the context of a moving car, this means that if the car suddenly stops, everything inside it, including the passengers, will continue moving forward at the same speed. When a car stops suddenly, our bodies want to keep moving forward. This is where the seatbelt comes into play. It acts as that external force, stopping our forward motion and keeping us securely in our seats. Without seatbelts, the risk of injury or even death increases significantly. The seatbelt provides a force that restrains us. This force is carefully calculated to be strong enough to stop us, but not so strong that it causes injury. This balance is achieved through rigorous testing and adherence to safety standards. Airbags also use Newton's laws to cushion the impact during a collision. When a crash occurs, sensors in the car detect the sudden deceleration and trigger the airbags to deploy. This happens in a fraction of a second, providing a cushion that absorbs some of the energy from the impact. They increase the time it takes for our bodies to come to a stop, reducing the force exerted on us. This is based on Newton's second law, which states that force is equal to mass times acceleration. By increasing the time over which the deceleration occurs, the force experienced by the passengers is reduced, thereby minimizing injuries. Another application of Newton's laws in vehicle safety is the design of crumple zones. These are areas of a vehicle that are designed to deform and crumple in a collision, absorbing some of the energy of the impact. This reduces the force transmitted to the occupants of the vehicle. Crumple zones work by increasing the time over which the collision occurs, similar to how airbags function. By extending the duration of the impact, the force experienced by the passengers is lessened, which can be the difference between a minor injury and a fatal one. In summary, Newton's laws of motion are integral to the design and function of modern vehicle safety features. From seatbelts to airbags to crumple zones, these principles help engineers create systems that protect us in the event of an accident. Understanding these laws not only gives us insight into the science behind safety, but also highlights the importance of using these features every time we get into a vehicle. Section 7. Sports and Newton's laws, a winning combination. Newton's laws are everywhere in sports. When a baseball player hits a home run, they are using Newton's second law. The force of the bat on the ball causes the ball to accelerate. In basketball, dribbling the ball is an example of applying forces to change the ball's motion. Every bounce is governed by Newton's laws. Section 8. Newton's legacy, the foundation of classical mechanics. Newton's laws of motion form the foundation of classical mechanics. Classical mechanics is the study of how objects move at everyday speeds. These laws are essential for understanding the world around us. Newton's work revolutionized our understanding of the universe. His laws are still used today in countless applications, from engineering to astronomy. Section 9. Conclusion: Newton's laws, a universe of understanding. Newton's laws of motion are fundamental principles that govern the motion of objects. They explain why things move, how they move, and the forces involved. By understanding these laws, we can better comprehend the world around us and beyond. Newton's laws are a testament to the power of scientific inquiry. They remind us that the universe is governed by laws that we can discover and understand.